So our first speaker is Justin Luong. He is an assistant professor at Poly Humboldt in rangeland management. And he got his PhD and Bachelor of Science in Environmental Studies at UC Santa Barbara with Loyal and Holl. So let's all welcome Justin.
Thank you, Jane. Hi, everyone. It's great to be here today. And my name is Justin Luong. I'm an assistant professor at Poly Humboldt and board member of the California Native Grassland Association. We have a booth over there, so you should check us out. Here's a QR code of this study if you're interested. And today I'll be talking a little bit more about the lessons learned from long-term restoration outcomes of California coastal grasslands. So California grasslands make up 25% of the state's area and are important both economically and ecologically. Grasslands support 90% of the state's threatened and endangered plant species and are often overlooked for conservation compared to other ecosystems, like those that plant a billion trees. California coastal grasslands and prairies are a small sliver of the 1% of remaining native grasslands in California, and they're typically characterized and dominated by perennial bunch grasses and annual and perennial forbs that also receive drought relief from summertime fog that contribute water during the dry season. Coastal prairies, however, are increasingly affected by land development, which can directly replace habitat and can also indirectly lead to indirect loss by increasing habitat fragmentation and changing disturbance patterns and facilitating invasive species invasions. Because coastal grasslands are also located in a legally designated coastal zone, they're often if they're affected, agencies are required to undertake compensatory mitigation or statutory restoration mandated by the California Coastal Commission or through county general plan documents. California is often thought to be one of the most diverse states in our country and one of the most diverse regions in the world. It's classified as a biodiversity hotspot with thousands of endemic plant species. And coastal grasslands are of particular interest because they have really rare, unique, herbaceous plant diversity. And oftentimes this diversity is attributed to annual and perennial forbs that are hard to restore, and which often leads practitioners to use more perennial species, perennial bunch grasses, leading to what we call perennialization, increased dominance of a perennial species, and also biotic homogenization, which is increased dominance by a few select species. And that could be concerning given future climate risk and habitat loss, and we might be concerned of all that rich biodiversity and some of these remnant habitats we might be losing. But there's also a lot of variability in restoration outcomes, and actually outcomes are relatively unknown. And that's because very few projects are resurveyed, so we don't really know what their success is after 5 years if they're a statutory or legally mandated project, and sometimes less. And projects that are not legally required or compensatory mitigation projects often don't even have any monitoring because there's not really an incentive and they don't have resources, and so we don't really know what's happening with those projects either. And these lack of funds for monitoring also lead to lack of funds for initial site assessment, so it's hard to also understand why some of these projects vary in their success and outcomes. Restoration also requires direct human intervention, and as such will also be shaped by the people or the persons undertaking the restoration. And it's been shown in various studies that sociopolitical and management and political factors play a defining role in shaping ecological outcomes, especially in practice in work that requires direct human intervention, like restoration. Some practitioners can even have different species preferences or landscape aesthetics preferences within the same agency, and so as such, practices and goals often differ across restoration agencies and even across practitioners within the same agency. And they also may differ because some projects may be classified as what we call statutory, which is a legally mandated project, and some projects may be classified as non-statutory, which is essentially voluntary or just someone decided to use discretionary funds for that project. But a commonality that usually ties together these projects is they tend to still be fund limited. And so to better understand restoration outcome, long-term restoration outcomes of coastal grassland projects, I asked 4 questions. Does coastal grassland restoration meet project-based and a standard performance metric? Is native cover related to project age? What are the biggest barriers for practitioners in achieving restoration goals of coastal grasslands? And how does funding and maintenance influence restoration outcomes? To answer these questions, I selected 37 restoration projects spanning a 1,000-kilometer range north-south from Santa Barbara to Humboldt counties. And to locate projects, I contacted a variety of land management agencies, preserves, restoration agencies, universities, government agencies, et cetera, previous contacts in restoration. And we found actually 48 sites possible, but some of the sites denied access, and so I wasn't able to revisit those and monitor those sites. And some of them I had already monitored more than 5 sites for. And so we ended up with 37 projects, and they were selected if they had planting and seeding efforts, since those are the most intensive. And we selected sites that were at least 3 years post-planting and seeding, since results can vary a lot in the first few years. We chose projects at least 1 acre in size, and those that were classified specifically as coastal grasslands, which are grasslands that receive summertime coastal fog. The projects selected ranged from 3 to 30 years post-implementation in 2019, and ranged from 1 to 32 acres in size. I conducted vegetation surveys from 2019 to 2021, and in 2019, I surveyed the first 32 sites I selected. In 2020, I surveyed 70% of the sites due to COVID-19 restrictions. And in 2021, I resurveyed about 80% of the original sites, and then added 5 new projects that I identified from management interviews, which I'll discuss next, which totaled 34 sites for that year and 37 projects in total. At each of these sites, I estimated absolute plant cover of all plant species and ground cover types in quarter-meter quadrats every 5 meters along 50-meter transects, and I used a minimum of 3 transects and a maximum of 16, depending on the site size. I also collected soil samples from the transects to characterize soils. Prior to conducting any of the vegetation surveys in the field, I conducted project document analyses, and so I reviewed any and all documents any of the agencies had about these restoration projects to better understand the species selection, the baseline data, the resources available for restoration, and I found that only 63% of the projects actually had these documents, and the information in these documents varied widely, and that some of them had all the information I was looking for and more, and some of them just had a planting list and a site description. And so after I conducted 2 years of the field surveys, vegetation surveys, I also then conducted semi-structured interviews and interviewed at least 1 or more practitioner from each of these restoration agencies to better understand, again, the resources for restoration, the barriers to achieving goal, implementation strategies, and to ask them to reflect on the results I had found from their specific restoration project and why they felt it turned out that specific way. And then I also asked them to fill in any information that I couldn't get during the document analyses. To start off with, we found that most of the projects I was able to survey were actually voluntary projects, and that something that was also, and statutory, just a reminder to everyone, is projects that are legally mandated by law. And one interesting thing that we found was that voluntary projects actually had typically achieved higher native cover and higher native species richness compared to, voluntary projects typically achieved higher species richness and native cover compared to statutory projects. And statutory projects often achieved lower non-native species cover. And access was sometimes denied to certain statutory sites, which were required to be restored in perpetuity, but they were never denied at voluntary projects. We found that there were 3 common barriers to achieving restoration goals. And the first one is no surprise. Practitioners from every single project indicated invasive species management was a top barrier to achieving their restoration goals. We found that 84% of projects indicated that there was insufficient funding to achieve their project goals or the quality that they desired for their restoration project. And of the 27 projects that responded that way, 74% indicated that if they had more funds, they would have conducted post implementation monitoring to better understand their outcomes and conduct adaptive management. About a third of the projects also indicated they had difficulty sourcing appropriate plant material or enough plant material. The good news is we did find that restoration is largely successful at reaching project-based goals. Project-based goals, of course, varied a lot, and they were always directional for voluntary projects, and usually numeric and quantitative for statutory projects, except for in the earlier years, they were also directional. And when I say directional, I mean increasing native cover or decreasing non-native cover or erosion. And oftentimes, it's pretty easy to reach those goals because you just have to change your cover by 1%, and technically that's a success. So we found 95%, all but 2 projects, reached their project-based goals, and then we wanted to compare it against a standard performance metric, which we set as 25% native cover and 6 native species after 5 years, which is kind of in line with kind of the lower standards required for statutory projects. And we chose this kind of lower level to be realistic since grasslands do suffer a lot of issues from invasive species, whereas other systems like forests and wetlands have these types of filters like flooding and intense shade that prevent as much invasion. And so we found 80% of the projects achieved the standard performance metric all across the 3 years, and about 6% of the projects met the cover goal but didn't meet the species richness goal, and about 13% of the project needed further improvement. We found that plant cover was relatively stable with project age, and that here on the x-axis we have project-based age as a proxy for time, and so it's not actually a sequence through time, but all these projects are different ages, and we find that the age is not related or correlated with native cover, which is not necessarily good news, but it's not bad news because maybe we might expect it might decrease over time with invasion. So native cover is pretty stable with project-based age. But we did find, unfortunately, a weak trend of increase of non-native cover over time or with project age, indicating that, of course, there's continuous invasions and that non-native species are increasing their cover. And that's an issue, of course, because non-native competition strongly impacts restoration efforts, and native cover is strongly and negatively related to non-native cover. And where there's higher non-native cover, there's lower native species cover, and there's also lower native species richness per unit area. We also found from our surveys that 88% of the projects typically use the same 7 species because they grow or survive better. And this could be concerning in the future if we continue to lose remnant habitat and only a subset of these species, which are all perennial bunch grasses, are restored. And three of these species, Stipapulchra, Elamis glaucus, and Bromus carinatus, were used at over 50% of these projects across this 1,000-kilometer range. We found specifically that financial cost had no specific direct effect on plant metrics that we evaluated, like going from left to right, native species richness, native cover, and non-native plant cover. But we did find that maintenance intensity or labor investment had effects, and that projects that had high and medium maintenance intensity typically had higher native species richness and higher native plant cover, whereas projects that had high maintenance intensity also had lower non-native plant cover. And likely financial cost wasn't directly related to these metrics because for some projects they were highly inflated for construction cost or removing concrete, for example, out of a decommissioned lumber mill, and other costs associated like that. We also found that using more species can counter biotic homogenization and improve the species richness at a site. On the left figure, we see the amount of species that different projects use, and we see that a majority of projects actually use 1 or 3 to 6 species, and very few projects use beyond 9 restoration species or unique species. And we, of course, found that probably is related to the fact that using more species is related to higher project costs per area. However, using more restoration species, as we see in the final figure, is related to higher native species richness per unit area. Overall, we found that grassland restoration is largely successful at reaching both project-based goals and a standard performance metric, but invasive species still limit restoration success, supported both through ecological surveys and management interviews. Projects also indicated they would have done more for their projects if they had more funding available. We also found there was difficulty in increasing regional diversity and difficulty in sourcing appropriate plant species and using new species because, of course, there was risk aversion to achieving restoration goals, and no one wants to use species they don't know are going to work well, and no one wants to fail at a project they're setting out to achieve. And so we can't really blame folks for using species that they know are going to work, but we need to really think about ways to kind of potentially coordinate restoration activities regionally and think about how to select species and essentially share this risk across agencies. And so one of the next steps we're doing is we're developing this grassland restoration network across the state. We have a survey here for anyone that does grassland restoration. Please take it if you do any type of grassland restoration or if you've been involved in grassland restoration, and please share it as widely as possible. We want to get as much feedback from practitioners as possible so we know how best to incorporate your feedback and how to best involve people in this network in the future to share resources to kind of help address some of this issue. I also have flyers that I can hand out afterwards. And of course, this project wouldn't have been possible with the numerous folks that helped me with the project and also the funding support, including the Northern California botanists. And with that, I'm happy to take any questions. Thank you.
Hello, I'm curious, you made a statement that species identification was poorer by consultants versus volunteers. What do you attribute that to?
Well, I'm not necessarily by consultants, just
Okay.
and not volunteers either. So voluntary projects are projects that land managers have discretionary funds like at the end of the year and they decide, okay, let's do this. Whereas someone that was interested in birds, for example, might do bird monitoring. And so those are what voluntary projects are. They're not necessarily like volunteer labor. And statutory projects, they are sometimes undertaken by consultants and sometimes undertaken by universities and other folks. And I can't really say exactly. Oftentimes, folks from what I've seen in the literature, voluntary projects are taken because they have immense passion for that topic. And because they have immense passion for that topic, they may also have more knowledge about that topic and may be invested in really kind of a personal investment in that project. But without kind of further study, I can't really say exactly why that happened.
Okay, thank you.
I may have missed the slide regarding the metrics of high maintenance versus low maintenance. Can you kind of explain what kind of metrics you use to make that sort of comparison?
Yeah, so low maintenance intensity was essentially when projects either had no maintenance or they just had an annual mowing event or they had continuous unmanaged grazing. So that's what low maintenance would be considered. Medium maintenance would essentially be multiple invasive species control efforts throughout the year and potentially a reseeding effort if the planting and seeding effort didn't take. High intensity would be numerous invasive species control efforts throughout the year, targeted invasive species control efforts, multiple reseeding and replanting efforts as needed.
So is that like looking at labor hours rather than costs in terms of maintenance?
No, looking at kind of what the activities they undertook, kind of like what they did annually on an estimated basis, because as I mentioned, most of these projects didn't have any documents.
Okay, thank you.
I was wondering, since invasives were such a problem, did you look at seeding versus using plugs? Because often plugs will hold a little bit better against the invasives.
Yeah, so I did look at that metric. We didn't necessarily find that there was a significant effect in these projects, and that could be because practitioners mindfully selected their methods. Because one of the questions I did ask them, I didn't present on today, is did they feel the seeding or planting was more successful? And it was really kind of, well, context dependent. Oftentimes, planting is more successful, but it's not really feasible at large scales and to use multiple species. And so we didn't find a direct effect, but practitioners do acknowledge that there are differences. Last question.
Hi, Justin. Great talk.
Thank you.
I might have missed it, but did you also analyze the different funding source types and amounts in relation to project outcomes?
Yeah, well, the funding, it was difficult to separate out total amounts. So I had total amounts from the funding sources, and it was, because the documentation was a lot poor for a lot of the projects, I wasn't able to determine, well, what was exactly allocated to construction versus actual restoration costs and the consultants for restoration and the on-the-ground effort. And so I was only able to analyze it at kind of the lump sum scale. And I can answer any questions later. Thank you.